Hi all, good morning. Till now we have covered this strength of materials or mechanics of materials up to shear force and bending moment diagram. Basically we have gone across. Before I proceed further, so till now we have done with the introduction part, right? Apart from that, we have also gone with the topics like stress, strain, then based on Poisson ratio, right? Then we have Young's modulus, then modulus of rigidity, right? Then we had volumetric strain, then we have generalized Hooke's law, then we had composite stresses on composite bars as well as thermal stresses, right? So we have basically studied about all this in our previous classes. So basically today's class will focus on the previous year questions as well as the model questions which are probably very important, and if you do this, I bet you that your fundamentals on this particular topics will be clear. So right, so without wasting time, let me start straight. I'll go with both, that is with the previous year questions of GATE, IES, and in the same time with model questions which have a probability to come in the examinations. Okay, so first I'll take a question. Here if you see, there's a question, and this is a question of previous year. The question has been asked, the second moment of circle above the diameter is given by D is the diameter, and here options are basically pi d4 by 4, this is pi d4 by 16, this is pi d4 by 32, and this is pi d4 by 64. What question is asking is the second moment of inertia. So the second moment of inertia is nothing but, if you take a circle, right, this is a circular area, so circular area have two axes. So second moment of inertia means what? It means the inertia about ixx and the inertia about iyy. So I, that is I for circle, is nothing but it's a combination of ixx plus iyy, correct? We want to know what is the second moment of inertia. This is our point of understanding. So moment of inertia for any circular body is given by pi d4 by 64, and same the condition for iyy, because diameter remains same throughout the circle for a same radius or same diameter. So when we do this, we come across 2 times pi d4 by 64. So when we cross this, we get it 32, that is pi d4 by 32, correct or not? So from here it is very clear that we will be getting the second moment of inertia as pi d4 by 32. But here this is the maximum time students do a mistake over here. If you see, pi d4 32 is also there in the option. This should not be done by the student. Why? Because question is asking the second moment of circular area about the diameter. So here you first have to write what? The polar moment of inertia. Polar moment of inertia is nothing but the inertia about x-axis and the inertia about y-axis. So when we put the values over here, we know moment of inertia about a polar axis for any circular body is pi d4 by 32. So I xx and iyy both are same no matter what they have. So I can write it 2 times of I, assuming ixx and iyy is equal to I, because diameter is same. So when you do this, so what happened? 2 times of inertia. So this is called as second moment of inertia. Therefore I will be pi d4 by 64. I hope this is clear to everyone. So here answer will be option D, that is pi d4 by 64. So this is how a question have to be approached. Clear? Now, I'll take one more question. So let me take one more question of previous year. So this is the question. Here it is telling a concentrated load, I'll repeat if it is not visible to someone, a concentrated load at P of P acts on a simple supported beam of a span L at a distance L by 3 from the left support. Okay, at a distance L by 3 from the left support, and here already it is discussing about simple supported beam. So let me take a simple supported beam. Simple supported beam means both ends it will be supported by what? Hinged support. It is telling a concentrated load P. A load P is acting on the beam, correct? At what distance? At a distance of L by 3 from the left end, correct or not? So, and the span of the or the length of this beam is what? L. So here what we are going to do is, if you take this, we have to find what is the bending moment for this, correct? So we know last time we have done for solving the bending moment, what we are doing last time, we are solving the shear force, SFD and BMD. So we are basically focused on this BMD. Now, but before we solve this, we have to see the reactions over here. Say this is A, this is B. So what happened? The reaction here will be RA, HA. Similarly here it is RB, this is HB. So here when we take the moment, it is what? RA plus RB is equal to P. Now if I take moments about A is equal to 0, what we get? We'll be getting RB into L minus P into L by 3. L got cancelled, so we got the value of RB as how much? We got the value of RB as P by 3. Now when we put the value of RB over here, that is RA plus RB, then therefore RA we will get P minus RB, and we have RB as P minus 3, P by 3. So this will be 2P by 3. So RA is 2P by 3, RB is P by 3. RA is 2P by 3, whereas RB is P by 3. Just now we have solved, right? See this. RB is P by 3. So RB I have taken P by 3. Similarly, horizontal, it will be cancelled because HA is equal to HB. So that will be cancel each other. Now we are focused over here to understand a bending moment. So bending moment about this point, say this point is O. So bending moment about O will be what? This will be like, this is O. From here this is RB, which is at perpendicular distance. So what will be the bending moment over here? RB into perpendicular distance. So what is the length over here? This is 2L by 3, because if this side is L by 3, the other side will be 2L by 3. So when we multiply this, what we get is, we get RB into, that is this point, will be RB into, that is moment about O, will be what? RB into length, that is 2L by 3. What is the value of RB? RB is P by 3 and this is 2L by 3. So this is 2 PL by 3 3 is a 9. So here options are the last, that is 2 PL by 9, correct? So this is how we solve the question, right? So this was again a previous year GATE questions. So this is how one have to approach. I hope this is clear to all. Similarly, we'll take a question, one more type, that is So let me frame the question. Okay, so this is the question. Here, this is again previous year question. Here, the question is, I'll increase bit more so that you can see properly. Okay, here the question is, two identical circular rods of same diameter and same length are subjected to same magnitude of axial tensile force. One of the rod is made up of mild steel having modulus of rigidity 206 gigapascal, that is, it is telling one of them modulus of elasticity is how much? 206 GPa. The other rod is made up of cast iron, right? One was mild steel. How much modulus of elasticity? So that is modulus of elasticity for steel is 206 gigapascal, whereas modulus of elasticity for cast iron is 100 gigapascal. Assume both the materials to be homogeneous and isotropic, and the axial force causes the same amount of uniform stress in both rods. The stresses developed are within the proportional limit of the respective materials. Which of the following is correct? First option, both rods elongate by the same amount. Mild steel rod elongates more than the cast iron. Cast iron rod elongates more than the mild steel rods. As the stresses are equal, strains are also equal in both sides. So if you see here, the discussion is with the elongation, means change in length or change in the extension, or it may be longitudinal extension, it may be lateral extension. Now for mild steel, since there is a discussion of the change in length, here let us start again from the beginning. Two identical circular rods of same diameter. So I'll take two circular diameter rods. So these are two circular identical rods, okay, of same dia. D is same, and length is also same, are subjected to same magnitude of tensile force. Both are subjected to same tensile force, okay. One of the rod is made out of mild steel. So this is a steel and this is cast iron. Assume both the materials to be homogeneous and isotropic, and the axial force causes the same amount of uniform stress in both the rods. So it is very clear, it is telling that uniform stress. So it will create uniform stress when it is in a composite. So this is from which topic? From the topic of composite stress or composite stresses in bars. So what was there? We have studied in our last class, whenever there will be discussion on composite stress, two things comes into picture. That is, the force applied or the force of pull or push will be equal to the force subjected to the steel as well as the cast iron, that is subjected to the all materials which are within. Apart from this, there we have learned the strain in body A is equal to the strain in body B. So these are the two things we can use in this particular question. So let me first use this, that is strain in steel, strain in steel is equal to strain in cast iron. So strain in steel will be what? Sigma S into LS into ES, correct? Here again this will be sigma C into LC again EC, but here we find the will find a relation between the stress. But what is our agenda? Our agenda is to find as per the what? Extension. So I will go for first extension of steel is what? PL by AES. Similarly, we'll go for cast iron PL by AEC. Now here what happened? Obviously both have, here clearly given in the question, both have same dia and same length. So we can omit this part out. So we'll be left with what? We'll be left with sigma ls is equal to P by AS and sigma LCI is equal to PL by EC. So here if I put the values, what we can do is, let us divide. Now here load is also same, even load can also be divided, right? So now we are left with sigma ls is equal to 1 by ES, sigma LC is equal to 1 by EC. From this 1 and 2 we can take it sigma ls by sigma C is equal to 1 by ES, and here it will be what? 1 by EC. So that is 1 by EC. So here the value of EC is what? 100 and 1 is 206. Therefore sigma ls by C, this is 100 by 206. So it is very clear that sigma ls is 2.06 times of sigma LC. So it is very clear that cast iron will elongate 2.06 times more of the steel. So here only C option is satisfying, that is cast iron rod elongates more than the mild steel. So for this answer will be this C. I hope this is clear to all. Right? Now similarly I'll take other problems. So we'll go to the next problem. Now let me take a question. This is of 2005. This question is from 2005. Okay, so the question is something this. And options are given as this. Here it is telling a beam is made up of two identical bars. Okay, a beam is made up of two identical bars, AB and BC. So this is A. Let me write it again. So this is A, this is B, and this is C, and here there is a load P. Okay, at a distance of L by 2. Okay, this is L by 2. I'll just change the color, it's not visible. So this is L by 2 distance from this particular point. So here question is asking that a beam is made up of two identical bars AB and BC. By hinging them together at B, the end A is built in cantilever end and the end C is simply supported. Now Apart from this, with the load P acting as shown the bending moment at A. What is the bending moment of A? Question is asking what is the bending moment at A. So let us first make the free body diagram of this. So if I make the free body diagram, how it is this is the beam, right? Okay, this is the beam. This is point B, and this point is P. Distance is L by 2, and the whole this part is up to here. It have a length L. Even from here to here the length is L, and this is hinge support. So when this is a hinge support, obviously when we make a free body diagram, this turns out to this, and here this is a cantilever beam. So obviously even here this will be replaced by this. So since this is A, I'll take it as RA, this is HA, this is moment about A. Similarly here this is point C, so RC, and here it is B as well. We have to find the bending moment at this point, correct, at A. For finding that bending moment, what is the bending moment at A? That is at A is equal to nothing but RC into L minus P into L plus L by 2, correct or not? This is what the bending moment for A. This is what we have to find, correct? Now for going into this, let us first clear out the value of RA and RC. So how can we find the value of RC? So how to proceed is, first we know there are two vertical forces, so take along y axis, that is RA plus RC is equal to P, correct? Now at B there is an internal hinge. This B is what? There is a hinge. So if you take moment about B is equal to 0, so we can take one section, that is RC into L, right, minus P from here, from this center, this to this. I am taking a moment about B. I am taking. Here also there is one perpendicular force, here also there is one perpendicular force. So RC is a perpendicular at the distance of L from point B. P is at a distance of L by 2 but in the opposite direction. Clear? So from here I'll get it. RC is equal to how much? RC is equal to P by 2. When I got RC is equal to P by 2, so if I put over here RC is equal to P by 2, so RA I will get it as P minus P by 2, that is again P by 2. So the value of RA and RC both are nothing but P by 2. Now we'll find the moment about A, taking moment about A. So what we get? We get RC into distance is 2L, right? Then minus P at a distance of L plus L by 2. From this point when we calculate, what happened here? One is this perpendicular, that is RC at a distance of L plus L. This is 2L, correct? Then again this P is perpendicular from this point. At what distance? This is L plus this L by 2. So here L plus L by 2. Apart from this, there is a moment in the anti-clockwise direction, right? But in the direction of RC. So MA is equal to 0. Now when we solve this, well, let's put the value. RC, we have the value of RC as P by 2. This is 2L. This is P. 2L plus 3L. 3L by 2 plus MA is equal to 0. So this is PL minus PL 3PL by 2, that is PL minus 3PL by 2 plus MA is equal to 0. So from there I can find the value of MA. MA will be what? 3PL by 2 minus PL, that is what we get finally, PL by 2. So the moment at A will be PL by 2. This is option B, that is PL by 2, correct. So that is how we go and we approach a question whenever it is given with shear force and bending moment diagram, which instead we have done earlier in our case. Clear? Now similarly we can take one more question. Say the question is, we'll take a GATE 2006 question. Let me frame the question first. This question is from 2006. So I'll discuss a question of 2006. Okay, here this question is of 2006. Just hold for a second until I frame the question. Okay, so this is a question. So anyway, I'll clarify again. So this is a bar, right, which have certain loads. This is 63 kilonewton. The end section is 63 kilonewton. Even at this end section, this is 21 kilonewton, but that is compressive. Whereas the middle bar is at 49 kilonewton as well as 35 kilonewton. What question is telling is a bar having a cross sectional area 700 mm square. Area is 700 mm square is subjected to an axial load at a positions indicated. The value of stress in the segment QR. It is asking the stress in which section? QR. Which is QR? This is P, this is Q, this is R, this is S. So the question is asking what is the stress in QR section. So we have already learned, and I have already discussed the last time, whenever there is a questions given on principle of superpositions, wherever the loads are not same and not constant, what we do is we treat them individual. So I'll first take individually the loads. Right. Now what was the rule in superposition? The first rule over this is always go with the extreme parts, extreme sections. So what are the extreme sections for us? It is PQ, QR, RS. So which are the extreme sections over here? The extreme section, if you see, it is always on the first section and the third section. So if you go to the first section, you can see the first section is tensile, whereas the PQ section is tensile with how much load? With 63 kilonewton load. Whereas the last section, that is RS, is with a compressive force of 21 kilonewton. Correct? This is 63 kilonewton PQ section. RS section is 21 kilonewton. So if you see here, what you have to do is first section PQ. If one side is tensile, by default the other side will also be tensile. So keep as it is, 63 kilonewton. Now if you go to the last section RS, see the last section RS, the end section there is a compression of 21 kilonewton. So obviously the other side also will be compression with 21 kilonewton. Correct or not? Now this is what I have done. See, I haven't done much over here. PQ section was having a tensile force of 63 kilonewton. I have taken 63 kilonewton. Okay, this is tensile as it is. See, this was tensile. So I have made tensile. So if one side is tensile, so other side will also be tensile. Similarly, if you go to the section RS, here 21 is compressive. So 21 is compressive on one side. So obviously the other side will also be compressive with 21 kilonewton. Now as per that, what we are going to do now, we have to 35 and 49 kilonewton. So how you can to do it, they do is, before taking this 35 and 49, just see over this PQ. See the section PQ, how it is going. This is tensile. So we have to make, so from this border Q, from the other section, there will be what? Opposite reaction. Correct? This is a opposite reaction. How much? Same. 63 kilonewton. It is just like if I push you with 63 kilonewton, you will also try to resist. How much load? How much load I will be giving you? That is 63. So if PQ, if load given by PQ to QR is 63 kilonewton, then there will be resistance source by QR. How much? 63 kilonewton. That is opposite. That is equal and opposite direction. Newton's third law. Right? Similarly, here if you see, this is 21 kilonewton to RS. Again, equal and opposite. 21 is equal, but it should be opposite to this. So this is how much? 21 kilonewton. Now, I'm not writing kilonewton. You must understand, this is because there is no space over here. It will be messy. That's why I'm avoiding writing kilonewton. Okay, but everything is in kilonewton. Now, after putting this, now go back to the question. See, section QR. This is section QR. If you take a point of section QR, what you get is, here 35 kilonewton is there, which is going towards the center. See here, 35 kilonewton, it is going towards the center. So here also you keep it towards the center. How much? 35. Here again 49 is going away from the center. So take 49 away from the center. So if you see here, 63 is tensile, so I'll write it 63. 35 is compressive, I'll write minus 35. Here 21 is compressive, I'll write it minus 21. 49 is tensile, so I'll write it 49. So if I subtract this part out of 13, if I take it 5, I'm left with 8. From 5, 3 gone, 28 plus 28. Now here also 49 out of 9, if I take it 1, it will be 8. Out of 4, if I take it 2, it will be 2. So this is what? Plus 28 plus 28. You can see here, this is plus 28. So we can say that this is section QR plus 28. So it should be tensile. That is 28 and 28. Whereas this first sections are already been assigned. That is PQ is tensile 63, 63, whereas RS, it is compressive with 21 kilonewton. Correct? So now we'll go back to the question. Question is asking, what is the stress in section QR? So stress in QR will be what? Force by area. What is the force? Force is 28 kilonewton. And what is the area? Area is 700 mm square. 700 mm square. So when we put the value over here, what we get is, what we'll get over here is quite clear, that it is have to go with a megapascal, and here if I take further, what we are going to get is as simple as 40 megapascal, right? Mega is what? 10 to the power 6 Newton per meter square. So meter square, when you take out to mm square, it will be again 10 to the power minus 6, sorry, 10 to the power 6 mm square. So this get cancelled. So finally you will come across 40. So answer is 40 megapascal. Clear? This is the answer. So it is only bit A, 40 megapascal, right? I hope this is clear to all. Similarly, I'll take now a different previous year question. I hope this is clear to everyone. So I'll take the next question. Before that, let me clear the board. So the next question is, a simple supported beam of some certain length, 6 centimeter, okay. Here it is telling a simple supported beam, okay, of span length of 6 meter and 75 dia carries uniformly distributed load of 1.5 kilonewton meter, right? So let me first make what it is talking about. It is simple supported, so obviously both side it will be supported by the reaction forces, right? Say this is A, this is B, this is A, this is B. So the reaction over here will be RA, reaction force over here will be RB. Is supported by a span of 6 meter. This is 6 meter, and this is a dia. The beam dia is how much? 75 That is, I'll put in the other color. This is 75 and carrying a uniformly distributed load of 1.5 kilonewton. So even this I'll put a different color. So this is carrying a uniformly distributed load throughout the section, right? How much? 1.5 kilonewton per meter. Means every meter the load exerted by the load to the beam is 1.5 kilonewton. Question is asking what is the maximum value of bending moment. Now to understand this, we have to first convert this into free body diagram, correct? So when we convert this to a free body diagram, what happened here is, this is RA, this is RB. So total load is how much? 1.5 into 6. Where it will act? Exactly in the middle. That is 3 meter and 3 meter. Between this whole force will act. How much? 1.5. So force will be 1.5 into 6. Correct? So now let us first, before finding the bending moment, what we have to do is we have to first find the value of reaction forces RA and RB. So how can we find? RA plus RB is equal to 1.5 into 6. One equation will get it. Now we can take moments about A or moment about B is equal to 0. So this time I will take moment about B. So what it will be? It will be RA into 6 minus 1.5 into 6, that is force, correct, into distance. At what distance? At a distance of 3 from the point RB equal to 0. So from here we will get the value of RA. So RA we will get it 4.5 kilonewton. So when we find the value, when we put here, we will get the value of RB again as 4.5 kilonewton. So we got the value of RA and RB as 4.5 kilonewton. So therefore moment, that is maximum bending moment, will be what? This 4.5, if bending moment will be what? At some distance. Say maximum bending moment is over here at this point, okay, at a distance of x, at this distance x. So we can say that RB into x minus 1.5 right? Whatever the load will be, this will be what? Say maximum bending moment is here. So this is the load, that is 1.5. At what distance? At a distance x into x by 2. So this will be RB x minus 1.5 x square by 2. So what we do is, by using this, now we'll check the value, and when we'll check here, what is telling, what is the maximum value of bending moment. So we can put the value here, and finally we'll come across a value 6.75 kilonewton meter. So this is nothing but, here if you see, nothing is matching, right? So when we solve this particular problem, what we do is, we have to take this maximum value. So maximum value, throughout the value, if you take, what is the value of x at B? X at B, moment at B, at the value of x equal to 0, moment at, say this is C, at x is equal to 3, and moment at A, x equal to 6. So by using this, we will come across 0. Then here if you put the value of 3, it is 4.5 into 3 minus 1.5 into 3 square by 2, and this is again 4.5 into 6 minus 1.5 into 6 square by 2. So out of this, obviously the whichever the maximum, that will be the value for you. Clear? So that is how we go for it. Similarly, the second bit, it is asking what is the maximum value of bending stress. So bending stress is nothing but, that is given by sigma by y is equal to m by I. So I here is what? This is nothing but beam. So here I will be pi d4 by 64, where here y will be d by 2, and obviously m we have calculated from this previous question. Only thing we are unknown is sigma, and that is what question is asking, that is m by I into y. So the value of m, you get it from this, the maximum, that is m what? Maximum max. So this will be maximum stress. I is pi d4 by 64, y is d by 2. So when we put this value, we get the values of the answer. Clear? I hope this is clear to all. Right? Now we'll go to the next question. This is a question from 2007. 2007. Okay, so the question is this. A simply supported beam loaded as shown below, the maximum moment in Newton meter will be how much? Okay, and the diagram is this. I hope this is visible to all. So this is the diagram. So here it's not getting bigger, so rather what I'll do is, I'll put the value, this is 500 mm, this is 500 mm. Here there is a load of 100 Newton, and the distance between this is 100 mm. Okay, This is the beam. Basically, there is a beam like this at a distance. This is the center. So from this distance, there is one more channel like this, and this is 100 kilonewton. At what distance? At a distance of 100 mm. This is 500 mm. This is 500 mm. Clear? Here question is asking, in a simple supported beam, that is, this is a simple supported beam, where will be the maximum bending moment? So when you see here this 100 into 100, it is very clear this is about this point, correct? About this point. So if I make a free body diagram, how it will look like? It is simple supported, so obviously there are reaction forces in both sides as well. That is, here you can see this is given as arrow marks. So if I convert this into free body diagram, this is, say, I'll take this side as A, this side is B. So A, B, reaction forces will be what? RA, RB. This is a point. Here, if you see this 100 into 100, how it is going? This is the beam. 100 is acting like this. So the beam will sag. When the beam sags, this will be in the direction of clockwise direction. So here, the moment will be 100 into 100. That is how much? 100 kilonewton into 100 mm. That is kilonewton mm. Now if I have to convert to Newton mm, how can I do is, say this 100, this is kilonewton, correct? This is 100 into kilonewton, sorry, it was Newton, not kilonewton, Newton mm. So this is 100 Newton, 100 Newton into 100 mm. So this is Newton mm. So if I have to convert to meter, so it will be what? 3 zeros will be going out. This will be Newton meter. So I can write, instead of this, I can write it 10 Newton meter. Correct? Now, if you make, let us make the shear force and bending moment diagram. But before making shear force and bending moment diagram, what? We are only concerned about the bending moment. So I'll only focus on that. Okay, so before that, we'll find the value. This is RA plus RB, right? Is equal to how much? Is equal to any load is there? Any load is falling. Yes, there is a load falling here. How much? 100 Newton. So this is 100. This 100 is nothing but, this will be equally carried by this, but because of a distance, there will be creation of a moment. So here I am replacing that with a free body diagram. So RA plus RB is equal to 100. Now if I take moments about A is equal to 0, what I get is 100, which is at a distance of how much? 500 mm. This is what? 0.5 meter, 0.5 meter. So this is 0.5 plus, this is 100. If I am taking this side plus, the opposite side will obviously negative, that is RB into what distance? At a distance of 1, correct? And then there is a moment again in the clockwise direction is equal to 0. So from here we will get the value of RB as 60 Newton. When we get the value of RB as 60 Newton, we will put it over here. So we will get it the value of RA as 40 Newton. So we got the reaction forces Ra and Rb. Once we get the value of Ra and Rb, that is Ra is how much? 40 Newton, Rb is 60 Newton. Now let us make the bending moment diagram. So when we go for the making bending moment diagram, so if I take, let's go by that way as I have discussed earlier. So if I take this as a section XX at a distance of x from right hand side, right, in that manner, if we go, how it looks, section, so this is OB, so section OB will be what, this is the section I have taken, this is B, RB I'll write directly 60 at a distance of x. So force in XX will be minus 60, whereas moment about XX will be 60 into x. So moment at B and moment at O. Moment at B at what distance? At a distance of x. Moment at A at a distance of 0.5 from B. So here moment will be 0 and here moment will be how much? Moment will be 60 into 0.5, that is nothing but half of 60, that is 30 Newton meter. Both are in positive side. Since we are making only bending moment diagram, so I only concentrate bending moment. So bending moment diagram, this is what? This is 0 and then this is 30 Newton meter. So now join this. Okay, next let us check. Question is asking what is the maximum bending. So maximum can be over here also, correct or not? So let us check that way. So now I'll go by the left hand section. If I go by left hand section, if I go by left hand section, I'll take a section XX, X from left side. So how it looks, so this will be something like this, XX, a load 40 Newton at a distance of x. So force along x, how the sign signature, see the sign signature of a shear force is what? This, right? This is for left hand side, this is for right hand side. If left hand side, if the forces are going up, it will be positive. So we are going from left hand side. So in left hand side, what is this? Force is going up. So it should be positive. So plus 40. Then again beam, if it is sagging, it will be negative. If it is hogging, it will be positive. So here when we give a force, this is the beam. When you give a force 40, what happens? This beams turns to this. So this is positive. Therefore moment about xx is equal to plus 40 into x. So moment at A, moment at O. Moment at A is equal to 0, correct? Moment at O is what? At a distance of 5.5. So at 0, this will be 0 Newton meter, and half of 40 is 20 Newton meter. So when you see here, at A it is 0 and at O it is 20. So 20 should lie somewhere down. So this is 20 Newton meter. So this is what? This is the bending moment diagram. So from here it is very clear what is the maximum bending moment, 30 Newton meter. So for this particular question, the answer is 30 Newton meter. How? This is the step. So this is how you can come across the value. Clear? I hope this is clear to all. Right? Now let us check for some other problems. So I'll take a question now from from gate 2010. So where is gated 2010? Gate 2010. Okay, got it. So here it's talking about you don't have to worry. I'm anyway going to explain this. Okay, so this is a question given, and it have again two bits in this particular question. I'll mention that as well. Okay, here the question is, a massless beam have a loading pattern of, as shown in the figure, the beam of a rectangular cross section which is a width of 30 mm and height is 100 mm. That is, B is 30 and H is 100 mm. This is a beam which is hinged at A with a hinge support, whereas at C it is with a roller support. First question, it is asking what? First it is asking the first bit. It is asking to find the maximum bending moment occurs at which point. Okay. Whereas bit B, it is asking maximum magnitude of bending stress. So let us go by the, I'll make the shear force and bending moment diagram to make it more clear. So this is a beam. There will be a reaction here, correct? RA. There will be reaction over here as well, that is RC. Here this is a hinge support, so obviously there is one more, HA. This is B, this is C, okay, ABC. And here uniform distributed load of how much? Of 3000 Newton meter, and this is of 2000 mm. So I can write it 2 meter, and this is again 2000 mm, so I can write it 2 meter. Okay. So now how can we do is, this is 3000 Newton per meter, this is 2000, and again this is 2000 mm, this is also 2000 mm. Okay. Now we have to make shear force and bending moment diagram over here, because then only we can get to know which have the maximum bending moment. So when we do this, now before that we need to find what? The value of RA and RB. So RA plus RB RA plus RB is equal to 3000, and it is expanded till how much length? 2 meter, right? So 3000 into 2, that is 6000, right? Now we'll take moment about A is equal to 0. So when we take moment about A is equal to 0, so this will be RC, which is at a distance of 4 minus force is how much? 3000 into 2. At what distance from A? At a distance of 2 plus 2 by 2, correct or not? Because this is uniform distributed load, the centroid will be exactly half. So this is the force which will be 2000 into 3000 into 2, that is 6000, which will be falling at a distance of this, that is 2 plus this part is what? This is 2 by 2, that is 1. So when this is equal to 0. So when we solve this, what we get is, we get the value of RC. We will get the value of RC as 4500 newtons. Now if you put the value of, sorry, not RC, okay, RA and RC, right? So when we put the value of RC as 4500, what we get it, therefore RA will get it how much? 6000 minus 4500, that is nothing but 1500 newtons, right? Now to understand this, now we'll go by our own method. Now for finding the maximum bending moment, I'll take a section XX at a distance of x from the extreme end RC. So I'll take this section XX, this is extreme end, this is RC. What is the value of RC? 4500 Newton at a distance of x. And what is this? There is a uniform distribution load, correct? So this uniformly distributed load is of 3000 Newton per meter, correct or not? So force about XX will be what? 3000 x, whereas moment about XX is 3000, that is force into perpendicular distance. What is the perpendicular distance? It is x by 2, because here though the force is expanding for the distance of x, but the centroid of this particular force, that is 3000 x, will fall exactly at x by 2 and x by 2. That's why this is x by 2. So we get it how much? We come across 3000 x square by 2, right? So here if x is 0, x plus 0 is x plus 0, x 0 plus 2 is 2. Similarly here it is x plus 4, another 2, right? So here what we see is 3000 x square by 2. Now when we put the value, if we want to know the moment at C and the moment at B, moment at C x equal to 0, moment at B x equal to 2. When we put the value, this is 0, and at 2 we get it as 3000 into 2 into 2 by 2. This is 6000 Newton meter, correct or not? So we come across what? That is 6000 Newton meter at B. But what question is asking here is the maximum bending moment occurs at which place? Okay. So this is 6000 Newton meter. So question is asking the maximum bending moment. So the maximum bending moment where it occurs? Wherever shear force will be 0, correct or not? So where shear force is getting 0? So let us check over here where shear force is getting 0. First case, 3000 into x. So obviously x equal to 0, this. So when we see over this, shear force will be 0 at x equal to 2.5. So answer for this will be option C, 2500 mm from the right of A. To understand this, you can check out over here. 2.5 means this is 2.5 means somewhere here. This distance is what? 2.5. How to check is RA into 2.5. If you have to check moment from here, if I take a moment from here, it will be what? At A, it will be Wx by 2 plus x, or if you go the moment by this end, it will be RA into 2.5 minus this particular distance, right? So when we calculate this, we will come across bit C. I hope this is clear to all. Similarly, the second bit, what it is asking, you have to use the value m by I is equal to sigma by y. So from here we get the value of sigma, that is what, m by I into y. Put the value, will come across the points, and here it is obviously when you calculate you will get 67.5, right? Is that clear to all? If there is any question, you can ask me. If anyone haven't understood, I'll repeat, that's not a big issue. Okay, fine. Here you can use the shortcut as well. From the options also you can find the value. How? From the option also you can do, because see, from 1 it is asking when bending moment occurs. When bending moments, where the bending moment will be more, when shear force will be 0, where shear force will be 0. If you take out this 2.5, so this will be how much? This is 2000, right? So this will be, say this is a distance x, so this will be how much? This will be x minus, this is x, this is 2, so this distance is x minus 2. So if you see in this way, that is Ra shear force minus 3000 x minus 2. Here 2675 is there, 23225 is there, 2500 is there. So let me try with this. Ra we have captured already, we have got the value of Ra, right? How much we got Ra? Ra is 1500, right? So check 1500, 3000 x, if I take it 2.5 minus 2, how much I get? 1500, and this is 3000.5 is nothing but 1500. We get it what? 0. So wherever shear force will be 0, bending moment will be maximum. That is what question was asking, maximum bending moment. So this is satisfying. Check, because other things if you check, no, 2.6 and 3.225, you won't be getting 0. So obviously B is not possible, D is not possible, A is also not possible. Obviously the answer is C. Similarly, bit 2, how can you do? We can do by bending moment equation, that is m by I is equal to sigma by y is equal to E by R. This is what? Bending moment equation, right? Now from bending moment equation I am using only this 2. So from here I can write it at m by I into y. So that is nothing but I by y. So this is m by z. So put the value as it is. Okay. So when you put the value, we will come across this, because bending moment you will be knowing. Bending moment is what? 1500. This bending moment will be 1500 into x. This is 1500, right? 1500 into x minus 3000. This is what? Force into centroidal axis. So when you put the value over here, you will get as at 0.25, at x equal to 2.5, you will get as 3375. So this is as simple as that, right? Anyway, I won't complex it, I won't make it complex. Let me erase this part. So m value how much we got? We got it 3375. I is BD cube by 12, BD cube by 12, and then y we can say is D by 2, right? So from here this is 6, D gone, this is square, So this is 3375 BD square, and here the value of B and D is given how much? 30 mm and 100 mm, right? So put the value of that 30 into 100, 3375, 6 is the right, so 6 get multiplied in the top into 6. B is 30, this is 100 square, and obviously this is in mm, so when we convert to meter this will be 10 per 9. So finally we will be coming across 6.67.5 into 10 per 6 Newton per meter square, that is 67.5 megapascal. And here we have only one option, that is 67.5 B, right? I hope this is clear to all. Okay, Michael is telling picture is blurry. Fine, Michael, I'll do one thing. I will write the question itself. Since it's a trouble for all of you guys, I should write the question itself. Okay. Now, I'll write the question itself. So let us take few model questions, which, if you understand these questions, I'm sure you can do any questions of any competitive exams wherever you go for writing mechanical engineering questions. Okay, so I'll write the question itself. So there is a problem, I'll write the question itself. Okay, don't worry. Question is, if the ratio G by K is equal to 0.3, then what is the value of the Poisson's ratio and the options are 0.2, 0.36, then we have 0.3, 0.33. I hope now there will be no chance of blurring. Okay, so Michael, your problem is understood, and hence I am taking in writing. Now I want everyone to go through this. If you remember, last time we have discussed about the relation between E and K, that is Young's modulus and bulk modulus. We have discussed the relation between E and G, that is modulus of elasticity and modulus of rigidity, whereas we have also discussed the relation between E, K and G, right? Now this is the question. Question is asking what? Poisson ratio. So what we need to find here is Poisson ratio. Now here what is given is G by K is equal to 0.3. Clear? So how can you do this? Whenever there is a discussion of G and K, three things comes into mind, right? One is E is equal to 2G 1 plus mu, which we have derived in our last class. E is equal to 3K 1 minus 2 mu. One more, E is equal to 9 kg by 3K plus G, where E is what? E is Young's modulus, G is modulus of rigidity, and K is bulk modulus. Correct? Now I'll use these two equations, this and this. Let me not use this as of now. If I use these two equations, what I see left hand side is common, that is E is common to E, therefore I can write it as 2G 1 plus mu is equal to 3K 1 minus 2 mu. Left hand side is same, that's why. Otherwise, in very simple, in this part of in value of here E, I am putting this value of E, same thing. Now when I do this, what I get is, I'll get 2g by 3k, correct? Let us solve this. Please solve, all of you along with me. 2g by 3k, this is 1 plus mu. 1 plus mu, mu is nothing but Poisson's ratio, right? And this is 1 minus 2 mu. We have the value of g by k, how much? 0.3. So 2 by 3, this is 0.3. 1 plus mu, so I'll take it, 1 plus mu is equal to 1 minus 2 mu. So when we solve this part will get it as 3 1 ja 3, so this is, we'll get it 0.2. 0.2, 1 plus mu is equal to 1 minus 2 mu. When I solve further, I'll get it 0.2 plus 0.2 mu is equal to 1 minus 2 mu. I'll bring mu one side, that is 2 point, this mu I'll bring this side, so this will be plus 2 mu. So 2.2 mu, 1 minus 0.2, it will be 0.8. Therefore mu will be 0.8 by 2.2. So finally we will get it 0.36. So our option is option B, 0.36. Is that understood to all? So I hope this is clear to all. Now I'll go for the next question. Next question is question number 2. A round bar of length L, elastic modulus E, and Poisson ratio and Poisson's ratio mu is subjected to an axial pull P, what would be the change in the volume of the bar? And the options are PL by 1 minus 2 mu E. B option is PL 1 minus 2 mu by E. Option C is PL mu by E. And option D, it is PL by mu E. Clear? A round bar of length L, a round bar means what? Cylindrical, correct? Of length L, elastic modulus E, and Poisson's ratio mu is subjected to an axial pull P. What would be the change in volume? Here question is asking what? What is the change in volume? Question is asking, right? So what it is? A round bar. So let me take a round bar. I'll take a round bar. So this is the round bar, correct? A round bar of length L. This is a round bar of length L, having elasticity E and Poisson ratio mu is subjected to an axial pull of P. This is subjected to an axial pull P. So this is what? This is very clear that this is a cylindrical object round bar. What would be the change in volume? So question is asking what is this? Correct? So how can we go for this? See, it is very clear. We know that volumetric change is what? Change in volume by original volume. So this change in volume by original volume is nothing but strain. We know strain is nothing but sigma x, sigma y, sigma z by E 1 minus 2 mu. We have just derived in our last class. This is what? This is dou V by V. Now from here, assuming sigma y and sigma z 0, because there is no discussion of 3-dimensional, so we can assume this as 0. So this will be what? Sigma x by E, sigma x by E 1 minus 2 mu is equal to delta V by V. So from here, sigma x I can write it as P by A, that is load by area. So this is P by AE 1 minus 2 mu. Correct? We can write like this, is equal to delta V by V. But what is the question asking? Question asking is the change in volume. So change in volume is what? P by AE 1 minus 2 mu into V. V is what? Area into length. So AA get cancelled. So we come across PL by E 1 minus 2 mu. Right? So let us check the option. VL by 1 minus 2E. So it is only option B which is matching. See, PL by 1 minus 2 mu, PL by, this is the one, right? So PL 1 minus 2U by E. So option B is right for this, right? So this is very easy. So that is how we solve questions for this. Michael, you have asked me where those 3 questions come from. Michael, to understand this, you have to watch my previous class where I have already explained the relation that how E is equal to K, how E is in terms of G, and how the relation of E, G and K have come. Last class we have already discussed this. So based on that derivative, we have derived this 3 equations of Young's modulus with respect to G, with respect to K and with respect to each other. So right. So which we have discussed from the last class. I am only doing the questions which I have already taught till last class. Okay. So all equations and all derivation have been done in the previous classes. If you want, you can go with the previous recording of the session. Clear? Derivation is not required if it is a gate, but obviously if you are going for ESE, that is IES exam, then obviously derivation will be required. I hope I am very clear on this. Okay. Now we'll go to the next question. Question number 3. Here, this question I will take it from a question of thermal stresses. The question is, a metal bar of length 100 mm is inserted between two rigid supports and its temperature is increased by 10 degree centigrade. If the coefficient of thermal expansion is, that is, if the alpha thermal coefficient is 12 into 10 to the power minus 6 per degree centigrade and E is 2 into 10 to the power minus 5 megapascal, the stress in the bar is, the stress in the bar is how much? And the options are 0, this is 12 megapascal, third is 24 megapascal, and D is 2400 megapascal. Clear? There is a metal bar of length 100 mm. It is inserted between two rigid supports. Okay. And its temperature is increased by how much? Its temperature is increased by 10 degree centigrade. A metal bar length 100 mm inserted by 10 degree. If alpha, that is nothing but coefficient of linear expansion, is given 12 into 10 to the power minus 6 and Young's modulus is given 2 into 10 to the power minus 5 megapascal. The stress in the bar is how much? Okay. So what we are going to do, this is from the normal, this is from thermal stress, and we know stress is equal to what? Stress is equal to strain into Young's modulus, correct or not? But here we are discussing with respect to what? With respect to temperature. So here strain will be alpha T into E, because strain because of temperature is nothing but alpha T, that is delta L is equal to alpha TL, correct? So using this in place of E I am writing alpha T. So when I put the value of alpha T over here, alpha value is given, that is 12 into 10 to the power minus 6. Temperature change is given, that is 10, right? As well as the value of E is also given, that is 2 into 10 to the power minus 5. So if you see here, everything is given. So directly you get the value of stress, that is 24 megapascal. And question is what? Question is asking about the stress. The stress in the bar is how much? So obviously it is answer C, 24 megapascal. Okay, I hope this is clear. Praful have asked me what topic I am going to take the next class. Praful, after the completion of all previous year and model questions of the chapters and topics which I have done so far, the next chapter I will be moving into the principal stress and principal strain, which is again a very important topic. Okay, so anyway, as of now we will be concentrating on the previous year questions and the model questions of the chapter 1, which we have already discussed so far, right? I hope you are clear on this. Now I'll take a next question. See, now the question is fourth question, fourth model question. Mu, if mu is Poisson ratio, right? You know all. Mu is Poisson's ratio, G is modulus of rigidity, and K is bulk modulus. This is a very easy question. Then mu is equal to 3K minus G by 2G plus 6K. This is one value given. Other option given is, I'll write the option down only so that parallelly I can solve. Option B is given as mu is equal to K minus G divided by 2g plus 6c. Then again mu value is given how much? 3k minus 2g divided by 2g plus 6k. Similarly, option D, k minus g by g plus 3k. Question is telling if mu is Poisson ratio, g is this, g is modulus of rigidity, k is bulk modulus, then which of this following is satisfying? As in the previous question already have discussed what? E have three values. If you see E, J, K, so we need to use these values. E is equal to 2g 1 plus mu, E is equal to 3k 1 minus 2 mu, E is equal to 9 kg 3k plus g. So by using this we have to find the value. Here everything is in terms of Poisson ratio, so obviously by using this we have to find in terms of Poisson ratio. So what I'll do is, here I will take this two equation. This is not required all time. This usually we take it when all the three values are given or two values are given and the third value is required, because here there is no mu, right? But we require in terms of mu. So what I'll do is, from this, say this is equation 1, this is equation 2. So left hand side is same, so we can write it 2g 1 plus mu is equal to 3k 1 minus 2 mu. So from here I can write it, what I can write, 2g plus 2 mu g is equal to 3k minus 6 mu k, correct? From here I'll take out 3k is there, I'll bring 2g this side, this will be 2g. 6 mu k I'll bring to the right hand side, okay? So it will be 2 mu g plus 6 mu k. So from here if I take out mu common, so this will be 2g plus 6k is equal to 3k minus 2g. So therefore mu is equal to 3k minus 2g divided by 2g plus 6k. So let us check which one is satisfying. 3k minus g, no, this is minus 2g, not satisfying. K minus g, no. 3k minus 2g, yes. Let us check the denominator, 2g plus 6k, yes. So option C is satisfying. So it will be option C, that is 3k minus 2g divided by 2g plus 3k, right? So I hope this is again clear to all, right? So now let's take one more question. Here question is, for an isentropic, or I'll take a for an isotropic, for an isotropic material which is homogeneous as well, homogeneous and linear elastic material which obeys Hooke's law. The number of the independent elastic constants will be, and the options are 1, this is 2, this is 3, and this is 6. What it's telling? It is telling for isotropic, homogeneous and linear elastic material which obeys Hooke's law. So obviously whichever obeys Hooke's law means what? Stress by strain, Young's modulus is equal to stress by strain. That equation we are going to form from Hooke's law by using Hooke's law. The number of independent elastic constant will be how much? Which are elastic constant? What are elastic constant? Elastic constants are nothing but E, G and K are nothing but elastic constants. So to understand this, let us go back to the linear stress and strain diagram. If you go to the stress and strain diagram, what happened? We have seen for a ductile material, the graph flows this way, right? What does it mean? It means if I take a plot A, point B, point C. So up to point A, what is this? This is nothing but elastic limit. It means if I increase a body with a pull P, what happen? This increases with some length. Or if I give a force in a compressive direction, it will decrease with some length L. So this is what? This increment decrement is because of the elasticity and plasticity of a body. So when we talk about the elastic constant, so E, G and K are nothing but elastic constant, that is your Young's modulus, your modulus of rigidity and bulk modulus, correct or not? So what is the relation between this? If this is, we come across with a relation E is equal to 2G 1 plus mu, E is equal to 3K 1 minus 2 mu, and again we have E is equal to 9 kg 3K plus G. If you see, this is the only equation where all three I can see can be formed. Here what is missing? Here K is missing, here G is missing, but in this case, so we cannot use this. So in this case all three are existing. So here it is talking about the number of independent elastic constants. So with respect to E, the number of elastic constants are K and G. So how many values? 2. So answer for this will be 2. Clear? So this is how we solve the question in correct. Praful have asked me, sir, from where the get more questions. Praful, that's why you don't have to worry. I am the single source. When I am taking so much of hard work to bring so many questions, so that your basics will be clear and you will be very much clear on the understanding of the subject. So you don't have to worry on much of the questions. Only thing is that you focus on your basics. Questions, there are plenty of books in the market. You take any book, doesn't matter. But until and unless your basics are clear, it will be very tough to understand. So that's why I am here to helping you out with your basics. Okay, and if you have any doubt, you can immediately put your questions. You can put in the chat box itself, either during the live class or at the other class. Okay, good morning, Pritam. So nice to see you again. Michael, you don't have to worry what Praful think. You have to worry about yourself. Clear? Anyway, getting to the next question. I'll get to the next question. Here, try to understand this question. This is again a very important question. A bar ABC, a bar ABC having length L, okay, length L and diameter D. I'm not writing in full, I hope you understand, and diameter D is composed of two material, okay, composed of two materials. Part AB of steel and part BC of aluminium if it is subjected to tensile force P, then the ratio of length of steel to length of aluminium to length of aluminium part will be so that both parts have same elongation. Right? Here E of steel is given as 3 times E of aluminium. Okay? And the diagram is given as this. This is P, this is P, this is steel, this is aluminium. Say this is length 1, length 2, this total is L length. Okay, and the dia is D for both. Clear? So this is what the question. See the diagram properly, and based on that, see the question again. So this is the bar, total length is L, some length say L1 for steel and some length L2 for aluminium. Okay. Now here what is given is a bar ABC having length L, D composed of two materials. Yes, already you have seen the diagram, part AB of the steel and part BC of the aluminium. If it is subjected to tensile force P, yes, it is a tensile force because the forces are what? Away from the center of gravity. Tensile force P, then the ratio of length of steel, to the length of aluminium will be so that both parts have same elongation. And options are given as, I'll write the options as well. Options are given as 2, 3, 4, 2 by 3. So this is what is given. So when it is a composite section, in composite section, what was the law? The law is force will be always with steel plus aluminium, as well as the change in length of steel will be always equal to the change in length of aluminium whenever it is subject to a composite, whenever we are discussing on composite stresses. Okay, so when change in length of steel is equal to change in length of aluminium, we can write it PL by AE for steel is equal to PL by AE for aluminium. So length, we don't know the length of both, load same for both, area same for both, E and L. So here we get it what? We get it LS by ES is equal to LA by EA. But here in the question again,
value of ES is given, right? What is that? ES is equal to 3 times the value of EA. So ES is 3 times the value of EA. So 3 times the value of EA. This is LA, this is EA. Get cancelled. So this we get it as LS by LA is equal to 3. Question was asking what? The ratio of LS by AL. How much we got? 3. So answer for this will be 3. So you can see how easy the question is. Only thing is that you should know how to approach a question properly. Clear? Similarly, we'll go to other question. So the next question, again, if the two pieces of material A and B have the same bulk modulus but value of Young's modulus of B is 1% greater than that of A. The value of modulus of rigidity of B in terms of EA and GA will be how much? Okay, where E is nothing but what? Young's modulus, G is modulus of rigidity. Okay, should not get confused. So A option is 99 EA GA by 99 EA minus 3 GA. Then option B, I'll go downwise only instead of writing left and right, so that I can solve it here itself without breakage. So option B is 101 EA GA by 101 EA minus 3 GA. Then this is 99 EA GA by 99 EA plus 3 GA, and the last option given here is 101 EA GA divided by 101 EA plus 3 GA. So what it is talking is, here it is talking that if there are two pieces, okay, if there are two pieces of material A and B have the same bulk modulus, okay, that is what is given here is same bulk modulus, that is K of A is equivalent to K of B, but the value of Young's modulus of B, correct, is what? 1% greater, that is 100 plus 1, that is 101% of EA. So this will be 1.01 EA. Next, the value of modulus of rigidity of B in terms of EA and GA will be how much? So question is asking the value of modulus of rigidity, that is G, in value of B and A. So what we can do is, we know the value of modulus of rigidity of B in terms of EA. So now we know E is equal to what? We have three questions: 2G 1 plus mu, 3K 1 minus 2 mu, and E 9 kg 3K plus G. So here what I can do is, I'll convert things in terms of K as well. Now here if I go in terms of K, how it will be? This, if we bring in terms of K, we can change it to EG divided by 9G minus 3E, that is 3 times 3G minus E. Basically what I am doing is, if you see here, it is talking about modulus of rigidity G and E. So I am trying to bring in terms of both E and G only. I am trying to keep in terms of E and G only. Right. Now this is the equation we have found. Here it's telling same bulk modulus. So here two pieces of material A and B have the same bulk material. Now what I will do is, I will take for A and B side, that is EA GA divided by 3 times GA minus E of A is equal to EB GB divided by 3 times GB minus EB. Correct? Now what I will do is, EB. What is EB? 1.01 of EA. So I'll put that value over there. That is EA GA divided by 3 GA minus EA is equal to 1.01 of EA GB divided by 3 times GB minus EB. So here, from here, EA will get cancelled, right? Then again here 3 will also get cancelled. So we are left with what? We are left with GA by 3GA minus EA is equal to 1.01 GB divided by 3 GB minus EB. Now if you see, everything is in terms of G and E, and that is why we have converted this, we have bought it in the form of E and G, this, right? So now what you do is, you keep simplifying. So when we simplify this further, what we get is, we'll be coming across GB. Let's do this. This will be 3GA GB, 3GA GB minus GA EB is equal to 3.03 GA GB minus 1.01 EA GB, right? So further, if we qualify, we simplify, what happen is, we get GB is equal to 1.01 EA GA divided by 1.01 EA minus 0.03 GA. So that is, GB is equal to 101 EA GA divided by 101 EA minus 3 GA. So GB is equal to 101 EA GA by 101 EA
3 GA. So 101, where are 101? This is 101 EA 3 GA, this is plus, so this is 1. Option B, correct? That is what? 101 EA GA, 101 E minus 3 GA, and this is what it was asking, right? GA will be how much? Click. So this is how one have to go by this. Okay. Now let us go to a different question. Question is this. Question is a steel bar of 4 meter length and uniform section of 1200 mm square is suspended vertically and loaded as shown in the figure. Okay, as shown in figure. The elongation of the R is E is equal to 2.05 into 10 power 5 Newton per mm square. Okay, and the diagram is, the figure is, okay, figure is this, and what else are given is a load is given shown here, as well as a load is shown here, as well as here. This length is 1.5 meter, 1.5 meter, 1.5 meter. Okay, a load is 40 kilonewton. This is 60 kilonewton, and this is 80 kilonewton. Now if you see here, this is the question. What question is given is a steel bar of 4 meter length and uniform section of 1200 meter square. Okay, area is 1200 meter square, is suspended vertically and loaded as shown in figure A. Okay, now what you have to find is, you have to find the elongation. What you have to find is the elongation of the bar. This is given, so question is asking to find the elongation, that is elongation of bar will be how much, and the options are A, B, C, D. So options of A is 2.15 mm, B is 3.75 mm, C is 1.077 mm, and D is 2.45 mm. Okay, so how we do this is, first we need to do the free body diagram. So when we do the free body diagram solution, if I go for the solution, how we have to do is we have to first bring the free body diagram. So this is one. I'll name it as A, B, C, D. So there should not be any confusion. A, B, okay, A, B, this is B, C, this is C, D. Now when we go by this, we have to find the value of all together. So let us check what is the load in each. So if you see here, this will take a load of how much? 40 plus 60 plus 80. How to understand it? This is, say AB is you and you are hanging from a roof, and on your leg there is one more person BC which is hanging on your leg, and again on his leg the person BC who is hanging on you, on BC again there is a person CD hanging on him. It means what? Now if you were alone, you would have taken a load of only 40 kilonewton. Only 40 kilonewton load is required from you. But if one more person joins you, what happens? The total load that will be exerted by your body is 40 plus 60. One more person if joins you, what will happen? Your total load that you need to exert is how much? 40 plus 60 plus 80, right? Similarly, for the case of C, what it will be? It will be 60 plus 80. Whereas for body CD, it will be only 80 kilonewtons, right or not? So here, what is the total load? Here load is 80 plus 60, 140 plus 40, how much? 180 kilonewton. Similarly here, 80 plus 60, that is 80 plus 60 is 140 kilonewton. Similarly here, this is 80 kilonewton. So if this is tensile, so obviously this is going to be tensile. If this part is tensile, here this will be tensile. If this is tensile, this is going to be tensile. So load in AB is how much? 180 kilonewton. Load in BC is how much? 140 kilonewton. Load in CD is how much? 80 kilonewton. Now not to confuse here, section AB, if this is you and you are hanging from a wall, how much force you require to come from the wall? 40 kilonewton. If someone else hangs on you, so how much extra you need to come up? 40 as well as 60, that is 100, right? Whereas in this third case, obviously only 80 is required, right? So in the first case, that is 40, 60 and 80. Second case, section BC, that will be 60 and 80, and section CD only 80. Therefore, change extension in AB will be what? PL by AE, where load is 180 kilonewton, length is given 1.5 meter for all, 1.5. A is also given in the question itself, right? This is A, 1200 meter mm square. So this is also given 1200. E is also given, that is 2.5 into 10 to the power 5, right? So similarly we can find out for sigma L for BC and CD. So in simple, if I tell, the total extension of the body is how much? Total extension is extension in AB, extension in BC and extension in CD. So this is PL by AE, PL by AE, PL by AE. This is what? This is for section AB. This is for BC and this is for CD. What is common in all? A and E is common in all, whereas load and length is different. Even L is common. So L A by E is common, only P is different. So PAB, PBC, PCD. So this will be length will be how much? 1.5 mm. So I can keep it in terms of mm only. That's not a big deal, right? View I'm changing for. So 1.5, so meter no mm, so it will be 1500. Area is 1200. Here it is given 1200, right? You can see here 1200 mm, right? Mm square, that is area. So 1200 E is 2 into how much was given E? E was given as 2.05 into 10 power 5. 2.05 into 10 power 5. PAB is how much? 180 kilonewton. PBC was 140 kilonewton. And then the last one was 80 kilonewton. So when we solve this, finally we come across 2.15 mm. So this is the total extension of the body which is carried. Right? So this is how we solve. So how much it is? 2.15. So the total extension over here is 2.15 mm. Right? So that is how we solve. So what is the concept is? This is the concept over here. Clear? I hope you are understanding with this. Right? Okay. Now let us go to the next question. Next question is a 1.5 meter long steel bar is having uniform diameter of 40 mm for a length of 1 meter, and in the next 0.5 meter its diameter gradually reduced from 40 mm to 20 mm. If axial tensile load of 160 kilonewton is applied on the bar, then elongation of bar in mm is how much? Where the value of E is given as 200 giganewton per meter square, and the options are: A is 1.2732, B is 1.061, C is 0.4244, and D it is
0.8488, right? Here question is given as a 1.5 meter long steel bar is having uniform dia. So we can say something like this, right? Steel bar is having 1.5 meter. Okay, steel bar is having uniform dia of 40 mm. So this is how much? 40 mm for a length of 1 meter, and in the next 0.5. So this is up to 1 meter. In the next 0.5, its diameter gradually reduced. So it's gradually reduced like this. Correct? How much? 0.5 meter. Gradually reduced from 40 mm to 20 mm. So this was 40. So this come to 20. So the end comes to 20. If axial load is 160 kilonewton, here if this is a axial load, is how much? 160 kilonewton. This is 160 kilonewton is applied on the bar, then elongation of the bar. So here again it is asking what? Elongation of the bar. Now this one I'll draw it more properly. Right, this is what it's telling, and it's telling that this is gradually reducing. Okay, this is what it is talking about, right? 1.5 long steel bar. So this is 1.5. meter, but what is telling? After 1 meter, the uniform. Let's have a. So this is 1, right? So 1 meter. This is 0.5 meter. In simple, I'll write it in mm because question is asking to find in terms of what? Mm. Correct, no? See here, question is asking what? In mm. So I'll keep everything in mm. So 1 meter, 1.5 meter. So this is up to 1 meter. So I'll write it as 1000 mm. This I can write it as 500 mm. This is how much? Dia. Dia is 40 mm, and this dia is 20 mm. Right? Here there is a axial pull. So this axial pull is how much? 160 kilonewton. What question is asking? The total extension. Question is asking the total extension. Say this is A, this is B, this is C. So question is asking change in length, that is total extension of what? So total extension is nothing but AB, and this is BC. But AB is what? AB is a uniform section. So here we can write it PL by AE. But this is what? This is a tapered section. So when this is a tapered section, so obviously it will be what? This will be 4PL by pi E d1 d2, right? We have already done this derivation on the first class itself. We have done this derivation. So now put the value P is common to both, right? So P is common to both. So here it will come out as L A. Even E is common to both, correct? Because material is same. So P by E will come out. Plus L by pi d1
d2, right? So this will be P is 160 kilonewton 10 to the power 3. E is how much? E is 200 giganewton per mm square. So this will be 2 into 10 to the power 5. Then this is L 1000. How I made this? Have you understood this? We are converting everything in terms of what? Mm. So what is given here? 200 giganewton meter square. So I can write it 200 into 10 to the power 9 Newton per meter square. So 1 meter is equal to how much? That is 200 into 9 Newton. We have to convert to mm. So 1 meter is equal to 1000, that is 10 to the power 3. This is 2, 10 to the power 6. So 200 into 10 to the power 9 minus 6 is what? Newton per mm square. That is 10 to the power minus 10 to the power 3. So 200 10 to the power 3. Then L is 1000. A is pi by 4. 40 mm, that is 0.4 square, plus next is 500 area, that is pi. D1 is 0.40, this is 0.20. So when we solve, we finally get the value of 1.2732 mm. This is what? The total extension of the body. I hope this is clear to everyone. 1.2732. So which is the option here? 1 point. So this is the one which is quite near. So obviously it is A, 1.2732. I hope this is clear to all. So now we'll move to the next question. Shori have asked, it's 4L. No, it's not 4L. It's change in length, that is delta L. Okay, anyway, I'll take the next question. So next question is, a tensile load 50 kilonewton is acting on a rod. Okay, I'll directly take the diagram. So what it is telling, a 50 kilonewton is directly acting. So I'll make as it is. A 50 kilonewton is acting on a rod, 50 mm dia. This dia is how much? 50 mm dia and 5 meter length. This length is 5 meter. Determine the length of a bore of 25. Determine a length of a bore, okay, of 25. So I'll write this one this side. So this is 50 mm. So determine the length of a bore. Bore means a drill is done of 25 mm that can be made in the central of the rod. So from this central axis, no, one boring operation I have carried away, that is nothing but a drilling operation. Okay, if the total extension is not to exceed by 25%. Okay, so I'll come back to that. So this is the boring part. So one hole have been started from the right edge, and this dia is nothing but 25 mm. Okay, Now this is 25 dia. So if total this is 5, we don't know up to, but we don't know what is the distance. What question is asking is, question is asking determine the length of the bore. So this is length of bore, LB. So question is asking the value of LB. So if this is LB, this will be what? The other section. This length let me first clear this. This is LB. So this is, we can take it this as what? 5 meter. So that is 500 mm minus LB. Correct, no? Because this is LB mm. Then we have obviously other things are there as it is. Only thing is telling is in the question that the total extension is not to exceed by, okay, should not be greater than 25% under same tensile load. What it means is basically the permissible load, it is telling that you take a permissible load only up to 25%, that is 100 plus 25%, that is 100 plus 25% of the permissible extent. Okay, so this is nothing but because of this what happened, there will be change in length. So we are going to find about this. So here the question I was asking, so using this, so this is given in the question. So this means this. So in simple we can say the question is given as this should not exceed by 25%, means up to 25% is possible. Just a second, I think there is some problem with my pen tab. Okay, into delta L. So here question is asking find the value of length of the boring. So very simple. So first let us find the total extension. Total extension is what? Area we know. What it is, pi by 4 d square, that is 50 mm. So area we get 1963.5 mm square. Then we have L, that is 5 into 1000. This is 5, correct? 5 meters, so this will be 5000 mm. Then the total extension is what? PL by AE. PL by AE. P we know 50 into 10 power 3. L we have 5000. A we have 1963.5 into E is also given. E is 2.05 into 10 power 5. So 2.05 into 10 power 5. So we get what? Total extension without the boring, without considering the boring. So that is how much? 0.621. Now it is telling that what is the area boring then? This area boring will be what? A is equal to pi by 4. This is 25. So this is nothing but 490.87 mm square. Right? So therefore here the permissible total extension we can say is permissible total extension is what? This is given, right? 1.25 into delta L, that is 0.621. So we get how much? 0.7763. This is what? Total extensions. And then we know total extension is nothing but without boring and with boring. So it is PL by AE, P comes out. So P by E, if I take out, this is L by A. For without boring part, this is L with boring, area with boring. So P is over 50 into 10 power 3. E will be 2.05 into 10 power 5. Length is 5000 minus LB, right? Divided by pi by 4, 50 square. This is LB, pi by 4, 25 square. This total is equal to 0.7763. So therefore LB is nothing but that is equal to 416.6 mm. So this is the answer. Clear? I hope this is clear to everyone, right? So this was all few questions. We'll be continuing the questions. See, Shaurya, you don't have to worry. If this is a calculation, no, you don't have to worry, because if like this question, all questions won't be having so lengthy. Few questions will be lengthy, few will be short, and few will be average. If it is lengthy for you, it will be lengthy for everyone. So you don't have to worry, because whenever questions are framed in GATE and IES, it is not like aptitude, where in 60 minutes you have to complete 70 questions. In GATE and IES, you get sufficient time to complete the paper. Okay, so you don't have to worry on this. If this is one kind of questions which have been very big in nature, so the other questions will be getting in a short form. Clear? So that is how the questions will be asked. Fine. So we'll take a break of half an hour and I'll come back again. We'll meet again sharply at 11:40. Okay, so the next class will continue this at 11:40 a.m. today itself, sharply, just 30 minutes from now. Fine. So thank you. See you again in after 30 minutes.